All right, so section 4.5 is the Hopital rule. Okay, so first of all, the Hopital rule, uh, it's a very handy technique to solve a limit problem, and that limit problem always is in a fraction form. Okay, and later on, we can see that there are some limit problem, although it looks like it's not in a fraction form, but we actually can convert it into the equivalent fraction form and then apply the L'Hopital rule to do that. Okay, and we start with a couple of examples and then to show you what is the L'Hopital rule. Okay, so let's first look at a limit problem. Okay, so as x approaches 0, 2x minus sine x over 3x. When we first learned how to evaluate a limit, and we always like to plug in to see what happens, right? And as you can see, if you substitute x with 0 on the top, you're going to have a 0, right? Because sine 0 is 0. And on the bottom, 3 times 0 is also 0. So you're going to have a 0 over 0 form. And we do have a name. This is called the indeterminate form, 0, 0 type. Okay. And under this situation, the L'Hopital rule, it said that limit, so let me write into this. So limit as x approaches a fx over g of x. Okay. So if fa equals g of a both equals 0, so yeah, this is exactly the situation. And the L'Hopital rule said that, okay, if the derivative for fx and gx both exist, and also g prime of x does not equal 0 on the corresponding interval here, and well, except at x equals a, then it's equivalent to this limit. In other words, guys, when we're trying to figure out this, the L'Hopital rule said that if we have a 0 over 0 indeterminate form, then this limit equals, takes the derivative of the top, which is 2 minus cosine of x over 3. Okay, over 3. So now, so those two limit are equivalent, and that's based on the L'Hopital rule. So two comments here. First of all, when we try to apply the L'Hopital rule, there is no quotient rule get involved. Okay, so often in the previous class, I taught some students will apply the L'Hopital rule as the derivative of this big fraction, apply the quotient. No, so the L'Hopital rule, it's the derivative of the top over the derivative of the bottom. And if you think about it, what is the meaning of the derivative of the top over the derivative of the bottom? Actually, guys, you can think about it, it's the numerator and denominator, they are both running, okay? And we are computing, the rate of the change, okay, of those runnings, which we take the derivative of the top, right? The rate of the change over the rate of the change on the bottom. So that's the derivative of the top over the derivative of the bottom. And each step you have to evaluate the limit. Okay, so for example, after apply the Hopital rule once, this is what we have. And if we evaluate this limit, in fact, this one works, right? So you're going to have 2 minus cosine 0, which is 1. So 2 minus 1 is 1 over 3. So we're done. Okay, so the limit equals 1 over 3. Okay, so it's very, very easy to work with. And look at another one. Okay, another example. Limit as x approaches 0, 1 minus cosine x over 3x minus 2x squared. Again, if you plug in x equals 0, you're going to see that you're going to have a 0 over 0 indeterminate form. And we can apply the L'Hopital rule, which the derivative of the numerator gives us the sine of x, right, over the derivative of the denominator, which is 3 minus 4x. Okay. So up to here, guys, we start to do the evaluation. If you plug 0 in, you're going to have 0 over 3, which is 0. So we're done. Okay. So very straightforward to do. And by the way, the L'Hopital rule also works for the one-side limit. Okay, guys. So if you have one-side limit and still it's a 0 over 0 in determined form, you can apply the L'Hopital rule. And every time when you trying to use the L'Hopital rule, you have to make sure that it's 0 over 0. Okay, so now let's look at another indeterminate form, infinity over infinity. Okay, and guys, you can think about it. In fact, 0 and 0 type and infinity over infinity type, they are mathematically equivalent. Why? Because you see, you have a 0 over 0. Do you agree this is true, right? So, and y over 0 is infinity, and y over 0 is also infinity. So 0, 0 over type, theoretically, it's equivalent to infinity over infinity form. Meaning, if you have one infinity over infinity, and of course, those infinities, it can be the combination of positive infinity over negative infinity, or negative infinity over positive infinity. Okay, so you can still use the L'Hopital rule to work on. So look at this one. As x goes to, let's see, positive infinity, ln of x over square root of x. This is infinity, this is infinity. So it works. It is one of the indeterminate form. So let's do that, which limit as x goes to infinity. The derivative of the top, which is 1 over x, right? The derivative of the bottom, we can rewrite it into x to the power 1 over 2. So it's 1 over 2 x to the power negative 1 over 2, right? And we can simplify this part a little bit more. So it's gonna be limit. Let's see. You're gonna have is you're gonna have this. Okay. Because this part is x to the power negative 1. And if you simplify, I give you it's x to the power of negative 1 over 2. And I will write it into 1 over x to the power 1 over 2. And 1 over 1 over 2, which is 2, flip. So it's here. And this limit should be easy to evaluate. You have 2 over infinity, so this limit is it's 0. Okay, it's 0. There is another equivalent indeterminate form, which is called the 0 multiply infinity. You can see, guys, for this 0 multiply infinity form, you can do infinity over 1 over 0, right? So it's equivalent to 0 times infinity. Then you're going to have an infinity over infinity form. Okay, so this is one way to think about it this way. Or you can rewrite this as 0 times 1 over 1 over infinity, just still 0 times infinity. But in this way, you convert it into 0 over 0 type. Okay, so either way, as you can see that the 0 over 0, infinity over infinity, 0 times infinity, these are kind of like the equivalent format. Okay, so now let us take a look at this problem here. Limit as x goes to infinity, so x times sine of 1 over x. Okay, so this is infinity. This is going to be sine of 0, which is 0. So it's infinity times 0. what you can do is we can actually have multiple ways to deal with this one. First of all, let me give you one um, a little bit tricky, but the idea is use substitution. Okay, so think about this, guys. If we let's see, we x goes to positive infinity,